Hello and welcome to the latest tutorial. So this time around we are going to be taking a look at shader graph. So shader graph is something that is available to us if we are using one of the scriptable render pipelines, so the universal or the high definition pipeline. So URP or HDRP. Universal used to be previously as it was called the lightweight pipeline. It's now called universal. So shader graph is a way that we can build up shaders in those pipelines and build them up visually using something called a node-based editor, where we place down different blocks, and we link them together, and we use that to create our particular shader. So we're going to take a look at that. Important thing with shader graph is it's not currently available in the built-in pipeline, and it's something where I'm not sure if it's ever going to be available in that pipeline. But it is there in the universal and the high definition ones. So let's start off with, we've got a very basic scene here, and we've got a few different objects. So first thing I'm going to do is create a simple shader graph. So we go to create, and then under shader graph, we'll have a bunch of different options here. Because I'm in the universal pipeline, I have a specific set for universal ones. We also have blank options, things like that. Now with this setting what we pick here, it's not a case of, okay, once we've set it as a lit one, then it always has to be a lit one. This just is setting up the initial defaults really for that particular shader. We can go and customize and change it afterwards. It's just going and setting what our initial defaults are. So I'm going to set this up, and I'm going to call this a altitude shader. So the idea behind this is it will color an object based upon its altitude, based upon its height. So I'm going to switch over the cube to using that. So similar to how we would set the shader for something in any other of the cases, we come to our material, we change the shader here. Now shader graphs will be grouped here under shader graphs. So I can select that, and then I can select my altitude shader. And we'll see a lot of the stuff disappears, color goes to a gray. That's expected. That's the default appearance that we will get there with this. So I'm going to open up that shader, and we'll take a look and see what shader graph looks like. So this is the general interface. We have over here under graph settings. So where I said that we could, if we set something as lit, we could always change it to unlit later. We've got those options here. We can see those same different ones that were there in the creation process are here. So if we need to make changes to that, we can do that here. We can change it so that it is supports transparency. By default, everything will be opaque, but we can enable transparency. We can control what faces get rendered, how it works with the depth buffer, different things like that. So those are settings where if you're used to writing the shaders in HLSL, these options here are the things that would normally be configured via pragmas typically. So where we would use pragmas for turning on how it works with the depth buffer, stuff like that, we can do that via this. So these are our settings for that we can change at any point in time. And then we've got our vertex program and our fragment program. So the shader graph doesn't currently support a geometry program, but it does have the vertex and fragment programs. So vertex program runs on the vertices, can do additional processing, things like that for them. So that's stuff where you could use that for transforming and manipulating the vertices. The fragment program is then handling the actual sort of generation of the particular pixel colors, stuff like that. So let's look at some of the things that we could do. So let's interact a little bit with the fragment program, and let's start off with something really simple. We just want to apply a tint, because we saw when we selected the material, there wasn't any options available to us here. We've got no outputs, inputs, nothing like that. So what we can do is over here, and this is what's referred to as the blackboard. So the blackboard, if we hit plus, we can add in a bunch of different options here. Not all of these are actually going to be inputs that get exposed in the inspector. Some of them will be, but not all of them are going to appear in the inspector. If I add in something like a color, and we'll call this tint color. So see how this has got a green dot next to it? And also if I click on it, you can see that it is exposed here. I could make it that it wasn't, then it's going to function like a constant. So that little green dot indicates something that is going to become available here. And if I actually save the asset, then we can see the tint color is now present. I can change the default tint color. So I'm going to make it that the default tint color is white. And I'm going to bring this in here. So you just drag it in, and then I can link it up. And as soon as I save this, then it saved it. Now I can change my tint color here, and the color of the object changes. So very easy to set up a parameter, have it be accessible there in the inspector. So that's cool. I want to have it, as I was saying, be able to be coloring something though based upon heights. This is a height shader, or altitude shader. So we want to be able to set some stuff there in terms of, okay, at this height, use this color and essentially a gradient. Now, one of the variable types we have here is a gradient, but as we'll see, gradients are not exposed, and the actual exposed option, we can't turn that on. So gradients can't actually be made accessible. What we can do though is we can add in just two colors, so one for at the lowest height, one for at the highest height, and then we can add in two floats to indicate what those heights actually are. The other thing we can do to make this nice and neat for organization is I can add in a category, which I can change this to color by height, and then within color by height I can add in min height, I can add in a max height, and we can set initial values for those. So the max height, I might make that 20. I can also then add in a color, so min height color. So this is something that definitely the shader graph makes really, really easy, is just setting up and configuring all of these variables is really quick and straightforward, which is great. So we've got those set up. We have our min height, our max height. So we know to get our color, we have a min height color and a max height color. So we could loop between those, but we need a 0 to 1 value. And that 0 to 1 value has to correspond to based upon our height. But our height is just going to be in unity units, in meters. So we need to be able to take that current height, that min and that max, and turn those into a 0 to 1 value, which we can actually do using something called an inverse loop, which is a much easier way of actually doing this. So we're going to look at how we set that up. So I'm just going to fix up the naming of this so it's consistent. So first thing is we need the object's height. So what I'm going to do is, because I'm doing this based upon the position, so I can add in a position node. And again, this is something that's quite cool with this. I can just select the space that I want this in. If I want my position in object space, I can get that. If I want it in view, world, tangent, any of the different ones, it's a matter of picking from a drop-down. Normally that's something where I would get a location and then I would need to get the appropriate transformation matrix and multiply it by that. In this case, I can just say, give me the position and I want the world position, which is really great. So that's good, but I need the Y value of that. So to grab that out, I have to actually use a split. And although it's saying red, green, blue, alpha, that's going to correspond to X is red, green is Y, blue is Z, alpha is not being used in this case. If it was a vector 4, the alpha would be the W component. So green is going to be our Y value in this case. So what I need to do is, so for my inverse lerp, I give it three things: the min, the max, and the current value, and it will give me back that 0 to 1. So if I drag out from here and type inverse lerp, you see it lists three options. So this is something where what it's going to do, depending upon which one of these I select, is that's which input to the inverse lerp it will connect up to. So will it be connecting my Y value to the minimum, which is A, to the maximum, which is B, or to the T value, which is the current value there of the height, which in this case, T is the one that I want. So I select that. And so now it's linked up. So I can then bring in my min and max height, link those up here like this. And so that is now going to be turning that height into a 0 to 1 value, which is cool. So then that gives me the majority of what I need to then do the lerping between the two colors. So again, drag out. This time I want a regular lerp. And again, I can say that the input, because the input's that progress value, that 0 to 1, so I can select that. And then I bring in my min and max height colors, link those up. Now for the moment, I'm going to ignore the tint color, but we'll have these connected up. So that's looking good. So if I save this, I'll now have the options here to configure. And we can see because I put these in a category, they're nicely grouped. I can adjust the colors here. So I'm going to make it that at the lowest height, it's kind of a grayishy green color. Looks pretty decent. Yeah, something like that. It's pretty good. And then at the highest point, we're going to go for a really, really bright sort of sky blue. So that's configured on it. And what we will notice is if I select our cube, and as I move it, the color changes because the shader is controlling the height. It is controlling the color based upon the height. So that's good. We've got one simple shader going, which is great. We want to add in our tinting. So tinting, the way we often end up doing that is a multiply. You do have options here where we can use something like a blend, where we could be controlling stuff, getting the opacity, can control the actual method of blending. So this could be a cool thing to be using instead. So what I'm going to do is just bring this over here. I have my tint color here. Now because this is an opaque shader, I'm going to just leave the opacity at 1. And we'll link that up. And then the output of this will go over here. So I could be controlling then the different blending modes that I want to have here. And we've got, if you've used a lot of programs like Photoshop, GIMP, things like that, we've got all of the options here. So we've got a lot of different ones that we could be using. The straightforward one of multiply. Lots of different things that we could be making use of for this, which is really cool. That's something where we can't go and control the mode externally in code. That's something that's just fixed by whatever we set here, but gives us a lot of options for how that actually blends in. And then if I save this, we can then, at the moment our tint color is white, but if we change that tint color, then we can see its impact, which is cool. And we could control, okay, that's using multiply at the moment. What if we change that to using burn, for example? So it's kind of a darkish reddy color at the moment. If I save that, then we can see it makes it a much more intense red color there. So that's cool. But this shader, you can see it starts to get a little bit messy, but we can actually clean this up a bit. So this here, where it's doing a blending based upon height, this is something that we might want to use in multiple different ones. So with those blocks for that selected, I can right click, go down to convert to, and I can make it a subgraph. So a subgraph, so what I then do is I name this color by height, and you'll see it turns it into, for the perspective of this thing, a single block, which makes it a lot easier, makes this immediately a lot neater. It also makes it a file here that we can then add into other shaders. So it's essentially giving us reusable chunks that we can bring into other ones. If we need to go and modify that, we absolutely still can. We can just double click on this, and then we can see we've got that here as our shader graph as well. We can just neaten everything up. We can even, if we wanted to, rename stuff here as well. So we can rename that to color. So it just has it that it's a little bit neater, means that then here it's showing us color as the correct one there for what the output is. So using sort of subgraphs like that, really, really handy. We can also select things and group them. So I'm going to reorganize this a little bit like that. And then I can come here, select all of these, and if I group that selection, then I could then rename this to color calculation, and this just gives me a block that I can now move this around quite easily. So it gives us some really nice tools for being able to organize, being able to keep our shader graphs neat. It is one of the things that can be a challenge with node-based editing of stuff, is that you can easily have things just become such a chaotic mess. It does happen super easily. Thankfully with this, we've got stuff for lining things up, which that's a big help. We've got stuff for being able to group, turn things into little subgraphs, stuff like that makes a big, big, big difference in being able to actually have this be manageable, which is really cool. So, okay, that's good. Let's do more. Let's look at a couple of other things, because we've got a few more objects here that we want to actually control. So I'm going to close these because we are done with those. But what I'm going to do is I'm going to create one that'll have some transparency in it. So we're going to create another shader graph. It'll again be a lit shader graph. And this will be fade towards top, or fade out shader, we'll call it. So the idea is going to be, this is going to be a shader that at the base of an object, it's at its full intensity. We see the full color there. At its highest points, it's going to be fully faded out. So we're going to change our capsule to use that. So capsule, switch it from shader graphs over to our fade out shader. Initially goes to gray, as we would expect. So, okay, for fading it out, that's going to mean we need to know stuff like the position of something. So that's fine. We already know we have our position information, so we can access our position. This time around, we actually don't want world space. We want the object space. So because we're using the relative height of something, so we're going to start with object space. Well, we need to know where it needs to be fading out above. So we're going to need fade start height. So anything above that point, it will be starting to fade out. We need to know how rapidly it's going to fade out. So we also need the fade end height. And just for consistency, we're also going to chuck in a tint color, just as a handy thing. And fade end height, I'm going to initially make that 1. So what we're wanting to do is if it's below 0, so if it's below that fade start height, we use the full intensity, otherwise we start fading it. So we're going to need the Y component, so that's fine. We split out, we know green will be Y. So okay, we have one scenario where it needs to fade, one scenario where it's constant. We could, and we do have the options for doing branches, but this is where we can do this using a step function. So in this case, the height is our input, and the edge is our fade start height. What this will do is if our height is below fade start height, we will get a value out of 0. If the value is above that, we get 1. So step function gives you 0 or 1. Really, really handy, and a way that you can avoid needing to do if statements, which is cool. And also a lot better for performance. So, okay, we know we've got something that's going to be 0 to 1, so that's cool. Let's work out then the actual sort of value where it's of the fade intensity. So an inverse lerp, because again, we need a 0 to 1. So we can do an inverse lerp. T is our input. We want fade start height, and you can bring these in multiple times. You don't need to only be using these once. So we've got our fade start and end heights. Trying to position these so that they are ideally as neat as possible. There we go. So, all right, we've got a 0 to 1 value. It's going to be 0 at the start height, 1 at the end height, which is not really ideal. We kind of want it to be the other way around. So that's easily done. If we just swap these, then we should have that coming through in the opposite way. We'll find out. The fact that it's colored it like that suggests it might not work. Okay, so it unfortunately doesn't handle that case, which is all right, because what we can then do is we can do a subtract, where we do 1 minus that output, because that output's going to be 0 to 1. We do 1 minus that. It's then going to flip it to 1 to 0. So, all right, that's good. So we have value there that'll work for the opacity. We need to change our graph so that it supports transparency. And you'll notice when we do that, we get an alpha value come through. So we are most of the way there of what we need. So this step function, when it is 0, we want to use the alpha as being 1. When it is 1, we want to use this value. So that's sort of how we want it to work. That's something where we could use a lerp. So you often see step used with a lerp, because when it's 1, it should use this. So if we set up a lerp and we say that this value is the t value, I'm going to bring these a bit over here. So if it's the t value, well, this is the maximum, and we say this is 1. What that should do then, we link that up to alpha. So we think about this. The height comes in, we grab the y value. If the y value is below our start height, so below that edge, the output here is going to be 0, which means this will use the minimum, which is 1. So the alpha will be set to 1. Otherwise, this is going to use a value of 1, which means it'll use whatever we've calculated here, which we're going to be taking that height. We're working out where between start and end it is, so by doing that inverse lerp. Then, because that goes from 0 to 1, we actually want it to go from 1 to 0. So we adjust this by doing a 1 minus of that value. So we're going to save that, and we can already see it fades out based upon the height there. And if I go to the material for that, and I can see I can adjust, I'm not using the tint color yet, but I will in a moment. I can also change the end height here, and we see it starts to fade out sooner. Can also, this fade start height, as I lower it, that changes where it actually kicks in that fade. And if we set it low enough, then it'll actually have it fully faded out. So that's pretty cool. We then, tint color is an easy one. It just gets linked up like that. As soon as that's done, that will properly set the color there. So really easy for linking up the tint color, and that makes it stand out a little bit easier. So, okay, that's pretty cool. We can color something based upon height. We've seen getting there and fading something out based upon height. The final thing that I want to show you is it's possible to use small little chunks of our own code in shaders via shader graphs. So we're going to take a look at how we can actually set up and use some bits of our custom code, because sometimes the blocks won't necessarily do what we need, or sometimes setting stuff up via the blocks, in particular if it's very math heavy, can be really sort of messy and convoluted. So we can set up little snippets of code for working with that. So we're going to set that up. Okay, so we're going to set up our sphere so we'll be able to use some custom code. So again, I'm going to create a lit shade graph, and we'll call this custom code demo shader. And we will set our sphere, to be using that. So again, all of them appear under shader graphs. This will immediately then go to gray, which is cool. So how these work is if we create a node and we type in custom. So we have this custom function option. And if we take a look at it, we can set up inputs, we can set up outputs, we can say whether it's a file or from a string, so we can actually just paste in code. I'm going to show you from a file, and we can set up things like function names, stuff like that. So what I'm going to do is I want one where input-wise, I want it to take in, we'll grab the, actually what we will grab is the normal, which we should be able to get that particular bit of information. So we can get our normal vector. World space is fine. So this, I'm going to give it an input that will be a vector 3, and that will be the normal. So I can drag that in, and I'm going to say that the output is going to be a vector 3, and that output is going to be the color. So this is what I want, something that takes in the normal and gives us out a color based upon that. So then what I'm going to do here is I need to create. Then I go to shader. Now it's not going to give me the right extension by default. That's fine. I'm just going to pick any of the particular ones and then I'm going to rename it. So we're going to change this to custom shader common, because we could have multiple functions in this. And I'm going to open this up, and then I'm going to change the extension for it. So we'll see at the moment the extension is .shader. So I'm going to change this. So the extension, I want the extension for this to be CG Ink. So CG Ink. And yep, it's going to get grumpy at me, so it might now not be usable. That's fine. So you can see it's got the particular file there. And then we actually nuke all of this stuff. So then what I want to do is, because this is something that's getting included, I need to actually set up some what's called header guards. So hash f ndef, so f not defined. So then we give this a name. Convention is usually that you use all uppercase. So custom shader common included. So if it is not defined, then we define it, and then we have at the end, we have an indef. So all of our code then goes in here. So then we need to set up our function. So we have our input and our output. So we have this, we'll call this color by normal. Now we need to indicate with this the precision. So we usually say float. Then we have our inputs. So we have a float 3 for the normal. And then our output, which is an output, float 3 color. So then we would say color is equal to normal. Now this is something that's really simple, but we could be doing more complicated things than this quite easily. So color by normal, that looks good. Then here we can select our source, which, because we named it CG Ink, it appears as an option. Then we can set the function name, which is color by normal. And you can see we don't need the float there. This float part is actually indicating the precision that we are working at. So float there is not part of the name we specify, it's actually controlling the behavior. So if I then save this, then what we'll see is it's actually coloring based upon the normal of the object. So really easy to link in custom code. Now I'm doing nothing particularly complicated here, but if we had to do a lot of intricate, complicated mathematics, this is an easier way of actually doing that. And it also means if we've got common stuff that our different shaders are using, that we can have them there in a common CG Ink file, and then that's able to be used across multiple different ones really, really easily, but we're still able to have the benefit of having things work via shader graph, which is really handy. Couple of things to watch for. The order of our inputs and our outputs matters. It is very important that the order that you have here matches. So inputs go first as parameters to the function and in the order they are listed here. Outputs go immediately after the inputs, and again, the order must match the order that you have here. This is really, really important. If you get the order wrong, then your function is going to be doing wrong things. It's going to be putting the wrong value into the wrong spot, and you will get incorrect results out of that. So you just want to be really, really cautious. But this can be a handy thing of if you've got existing code that you want to plug stuff into, you can be doing that via just using this setup. So you can take those functions from your existing code, convert them over into that CG Ink format. So set up the standalone little functions, rename them as needed, and then access them in this. So you can start to progressively bring code over into shader graph. So it means if you've already got a bunch of existing shaders with functions there, none of that stuff is wasted. You can update it and bring it across as you need to, which is really cool. So, okay, we did the changing of that. Is there anything else that we can potentially do? And kind of the answer is yes, because we have there's a lot of things in here. There's a lot of things we haven't made use of. You know, you have stuff here for things like noise, stuff like that. So you can generate a whole bunch of different noise and attach that onto things. So for example, if I grab this noise that's giving me a 0 to 1 output value, so I could, I'm going to go even a little bit more colorful with this. And I could then, what if I wired that into something like the alpha here? So then we get this really sort of cool patchworky pattern on there, which is very cool. So we've got different noise functions we could be connecting in. We could be connecting in things like time. So we actually, if we go time, so this is something where in a shader you might have something where you want it to actually change over time. And so the time block immediately gives us access to time. We have things like sine and cosine and delta and smooth deltas all available to us. So really, really handy if you wanted to have something where it's changing value over time. This is how you can then access that. So for example, I could be adjusting stuff here. So sine of time is going to go between 0 and 1. What I'm going to say is if I take that and I add 1 to it, then it is going to go from 0 to 2. So rather than being -1 to 1. So now this is going to go from 0 to 2. And so, okay, 0 to 2, that's cool. I could, what's it going to do if I wire this into the angle offset here? And that looks like that's potentially going to be kind of cool. So we need to be running. But if I have this running, then we'll get it properly ticking through a little bit more consistently. Then you can see it's slowly shifting. If I bring the camera in even closer, we'll be able to see it better. So we have something that's slowly shifting and changing over time with a fairly easily added effect. So quite easy to add in things like time. We can expose and change these settings quite easily. Really, really handy. There's a lot of stuff built in, and as you can see when you go to create node, there's noises. We've got stuff for working with shapes, checkerboards, you name it. There's a lot of different things here that we can access and a lot of really cool things that we can be doing with this. So dive on in and experiment with the stuff that you can do with Shader Graph. I'm going to be doing some further videos showing you some specific effects in Shader Graph, how to actually create those. So there'll be more ones that I'm going to be doing on this. But dive in and have a bit of an experiment with it. See the kinds of things you can do. Take these existing shaders and mess with them a bit. Try and change around if there's particular effects you're after. See if you can set those up and get those up and running with it. Thanks folks, I hope you found the video helpful. If you're looking for the code for the project, you'll find that available up on GitHub. You can use that for any of your own projects, commercial, non-commercial ones, you're free to be using that. If you have found the video helpful, please chuck in a like and subscribe. Something really helps out, it's really appreciated. And if you've got any questions, chuck in a comment below. And if you're looking for other ways to support the channel, then I do have a Patreon, and you'll find the link for that in the description below as well. But until next time,